Hi, and welcome to the FiatLuxLabs demo. Our sensor works by extracting fluid samples from a fermenter or bioreactor as represented by the carboy to the right, and continuously measuring the ATP in those samples. When graphed over time, these measurements can be characterized as either contaminated or not based on a classifier that we trained on a dataset we built in-house. We use yeast and test tubes to transduce the ATP in the system to light information, which can be used for analysis. This rig is the V1 of our sensor, and it is also what we've done to automate the data collection process we used to build our dataset. Normally the device would be placed in a shell as the yeast needs total darkness to be detected, but here it's opened to be able to see inside. In addition, test tubes and yeast would be included on the rotor if measurements were actually being taken. Here, we see the fluid being extracted by the device and the rotor turning to the next sample. All of this being timed at specific intervals so a sample can be taken every hour. The data is then pushed to a server where it can be analyzed and incorporated in our dataset. Here is the aggregated average of ATP levels in normal fermentations without contamination. We can drop in test data, which will be characterized as contaminated or not. Our first test is a non-contaminated sample and is characterized as such. Our second test is a sample we artificially contaminated at hour 10, and as you can see, it is categorized accordingly. Eventually, the end user will be able to log into our server and see a % chance of contamination of a specific contaminant. Thank you for your time, and please reach out with any comments, questions, or concerns.